absence.
Hello. Welcome. My name is Taylor Brown.
And I'm Arno Miem, and we're both program managers in the Windows Operating Systems group, Hyper-V and Windows kernel. And today we're going to talk to you about Microsoft containers. In our agenda, we want to make sure that you get the knowledge to be able to have very meaningful conversations. You know enough about containers, so to speak, to be dangerous. We want you to gain insights on how you use containers and what containers are good for. And last not least, we want you to learn what Microsoft specifically is doing in respect to the container space. Let's step a little bit back and look at the data center from a historic point of view. Traditionally, in data centers, we used physical machines to deploy workloads. So we had the physical systems, we installed operating systems on them, and applications into those. As physical machines, though, started to grow in respect to their capabilities, you basically hosted multiple workloads within one system. That had multiple challenges with it from an isolation perspective in respect to install as well as performance isolation. This is where virtual machine technology came in. And with virtual machine technology, basically, you created smaller versions of a physical server. You installed the operating system and the applications as you did before. So you didn't need to change the paradigm of deployment for the application per se, but you gained greater isolation through that technology. That technology then enabled to host different workloads on the same infrastructure, side by side, due to the isolation properties. And on top of this infrastructure, basically new services started to evolve. It's basically started out with IaaS, and IaaS is essentially virtual machines that are hosted. So you, as a user of IaaS, no longer need to take care of the physical infrastructure that is done for you by a service provider. A step further was PaaS. And with PaaS, you no longer actually took care of the operating system in the virtual machine itself, but you focused essentially on your application itself. And the rest of the stuff was done for you by the service provider. And then last not least, with SaaS, you had the opportunity to only consume the service, and somebody else made sure that the service runs appropriately. However, all those were still built on the paradigm of the installation of an application into an operating system. They all typically used virtual machine technology in order to be more flexible. However, the cloud demands even higher agility. We need to find ways to separate the operating system from the application in respect to the runtime requirements as well as in respect to the installation requirements. That enables a new DevOps model that we can move forward with and gain new efficiencies. Now let me talk a little bit about the parts of the container ecosystem. What things really make up this container thing? Now first, we have a container runtime. And the container runtime is really the isolation boundary that you have provided by the operating system itself. And that is true for Windows and it is true for Linux as well. And within that boundary, you run a view of the operating system and you run your application. In order to aggregate the functionality in such a container runtime, you use an image layer system. You typically start out with an operating system, and on top of that, you layer functionality. And that functionality is captured in something that we call images. And by doing so, you create a very, very flexible system where you have a base and then you have, so to speak, Lego blocks you just put on top in order to aggregate what you need in order to run your application or fulfill your scenario. Now, because you have those very self-contained images, you are actually able to share them among multiple parties. And that's where an image repository comes in. Those individual images are immutable. They do not change. They do not change when a container uses them. And so multiple containers can actually refer to the same image in a very, very efficient manner. Let me dive a little bit into the container runtime and the differences that you see between a physical install, a virtual machine install, and a container install, in quotes, of applications. So let's start out. We have here a physical system. We traditionally install our operating system on top of that. And then we would install our applications in there. As soon as you install the application actually into the operating system, from a management perspective, those applications typically become almost a part of the operating system. It's one big blob. And what we did in the past is we took this and generalized it and used that as a golden image that then could be replicated across the hardware, right? Now, what does it look like when we do that in a virtual machine? As I said in my introduction before, in a virtual machine, we basically replicate what you had on the physical side. So we have no longer physical hardware, but we have now virtual hardware as depicted here in this top layer. On top of that virtual hardware, we again run a standard operating system. And again, we install applications into that operating system. Because of the isolation properties of a virtual machine, you can run multiples of those side by side on a system. However, each of them has its own operating system. And we still follow the paradigm of an image. And what you see today in virtual machine deployments very often, you still run with golden images and then start configuration after that. Now let's compare that, what it looks like for containers. Again, we have our physical system with an operating system on top of that. However, now what we do is we introduce a operating system virtualization layer. And that essentially is a layer that lives between the user mode and the kernel mode. And by introducing that this separation, we actually can create boundaries in which you run an application. And in fact, this is so efficient that you can run many applications side by side without impacting each other. Now, I said that has operating system virtualization. What does it mean? Can I now run it in a virtual machine as well? Absolutely, yes, you can. As a virtual machine follows this paradigm that a physical system follows from a layering perspective, you just install your operating system in there and then create containers on top of that, side by side and well isolated. Now, let's talk a little bit about how we create the functionality layers inside the container. First of all, what you see here depicted is a local repository on one side, and we have a view what it would look from inside the container as far as the file system is, as far as we look at the file system. So here we have a Windows Server OS. And so on the system itself, it's essentially C Windows, it's users, it's program files, the regular thing that you would see when you install Windows and don't do any further configuration. Now, if we start a container, what we do under the covers, we actually create a sandbox area. And the purpose of the sandbox area is to capture all writes that this container does. An operating system, obviously, when it executes, it writes things. When you install things, they get written. So we capture that in the sandbox because, remember, the image itself that you started the container with is immutable. It does not change. Now, from a container view perspective, the container just sees Windows. It just thinks it's running on regular Windows. It cannot tell the difference. Now, let's install a framework into that. Here, for example, we install Node.js into the container. And as it is a changing operation, a write operation, Basically, the container sees now the new directory, Node.js, right? But because it was written, it only lands in the sandbox. It does not trickle down to the original image. When we switch off the container, we can preserve the content of that sandbox. And what you can do is you turn that sandbox into a new immutable image. Once you have that image, you can share it out onto the repository. So other containers on your system can actually take advantage of that new image layer. They can take advantage of this new functionality that you have packaged up. And they can basically say, I start not from the base OS that was provided, I start actually from the application framework that somebody created for me. And when you do that, it would look essentially like you see here in the picture. From a container view, the container sees, again, Windows and Node.js. Again, it can't tell the difference between that and running in a virtual machine or running in a physical entity. And as the container runs, we again have created a sandbox to capture further writes, because all images are immutable. Now we install into that container an application that maybe takes advantage of the application framework that we have installed before. Again, the application write is captured in the sandbox. Again, the container thinks it's just in my C drive. And again, we can switch off the container, preserve the state that is in that sandbox area, in the file system, and make an immutable package out of that. And can share that immutable package also into the repository for others to use. So there's a lot of reuse possible in this scenario. You can also see that those are more independent layers. Nothing gets actually installed into each other, but each one of them is a layer on its own, which can be deployed independently. And with that, I would like to hand over to Taylor to give a demonstration.
All right, demo time. So I was thinking about this a little earlier. You guys probably like demos more than slides, yeah? So as we go through the slides, I'm going to go a little faster through the slides, and then at the end, we'll save some time and do a couple extra demos. We'll figure out what we can do. So what we're looking at here is we've got a virtual machine, and this virtual machine is actually running the Docker engine. So this is work we're doing with Docker and the open source. And what Docker allows us to do is it allows us to manage containers. It's a tool set for creating containers and managing containers. And so we've got our virtual machine set up, and I've actually got Docker talking to that virtual machine remotely. So I can say things like Docker images. And that'll list all the images that are in my local repository. And so we've got one Windows Server Core, and I can say something like Docker run, and I'm going to say --rm, which says, when this container goes away, automatically throw away the sandbox that Arno talked about a minute ago. Get rid of it. I don't ever want to see it again. This is just going to be a temporary container. And then I'm going to say -it, which says, give me an interactive console with this container image. And then I'm going to give the name of the image and the program I want it to run. In this case, I'll say command. So that's going to start a container. And just a second here, we'll have a new instance, a new view of Windows running from within this virtual machine. There we go. Who's ever seen Windows start that fast? Yeah? So we've got our container host, right? And we can look at it, and it's running version 10060 of Windows, and we can see the containers doing the same thing. And the actual machine that I'm running on is running a different build, because these are all completely isolated views. This container is its own view on the operating system. I can do directory listings. I can do something like delete, right? It's gone. I can come down and say Docker run. And I can start another container up. And as soon as this starts, we'll see that the same files I deleted in the other one, they're back. right? Because this is a new container. It's got its own view on the world. I can do something really fun like reg delete HKLM software. I don't advise doing this at home unless you really don't like yourself. Right? It's gone, so I can still do directory listings, but I can't do like command doesn't work and ipconfig doesn't work, right? But as soon as I type exit, that container's gone. All of my misgivings have been erased. It's gone, right? This is a really simple and quick view of kind of what containers are, and as we go into more demos in a moment, we'll look at a little deeper. But I think it's kind of important to look at what the process of using containers in a development lifecycle looks like, right? So we've got on the central repository, and the central repository could be a cloud service, it could be something like Docker Hub, it could be a repository within your own company, it could actually be a repository on your machine, but it's got a set of container images in it, right? And then I've got a local repository, which is kind of where I'm doing my development. That's probably on my laptop. That's somewhere that I'm actually doing work. And so the first thing I do if I'm starting a new project is I figure out what I'm going to use to write that project in. Am I going to use .NET? Am I going to use Node.js? Am I going to use PHP? What application framework am I going to use? And then I can simply go up to the central repository and pull a copy of it over. Now, I don't actually have to worry about any dependencies. I just pull over the application framework I want. The dependencies will come automatically because the layers describe their dependency relationships. So the application framework layer knows that it was built against that version of Windows and that image. It's going to bring that across automatically. Now I go off and I do some work. I write some code, I do some development. I compile it the same way. Maybe I put it into a source repository system, it gets compiled. And here's where the next new step is. I actually create a new container image. And when I did that, what I simply do is I install my application or I copy my application into a container, just the same way I would if I was copying it over to a virtual machine. But now I've created this immutable image. And I can push that back to that repository. So now everybody who I want to can use my image, or just me. And so if I want to go do unit testing, this is actually incredibly powerful for unit testing because I can run the exact same code every time in a unit test. My unit test will run the exact same way. I can share it with another developer, so he can use my code the exact same way. So if I'm on a team that's doing, let's say I've got a guy down the hall who's doing the database, I'm doing a middle tier, and Arno's writing the website. I can just give Arno my container image of the middle tier, and the database guy can give Arno the container image for the database, and he can just work on the website. He doesn't have to worry about installing my code and running my scripts to install stuff, or us agreeing about a framework. It doesn't really matter anymore. He just takes the container image. And we can stage this out for integration in QA. So they get to run the exact same thing that we were running before. And then we kind of get into what's the full DevOps life cycle. So we talked about our developer, and we talked about pushing that in. Well, now operations can come along and automate scaling that out and pushing it out to the cloud. And so they can say, you know what, we know that we need 3 copies of this application running. We need it to be geographically dispersed. We need it to be on-prem, or we need it to be in Azure. All of those decisions become the operations team's decisions. So they push that stuff out to the cloud. Now, as the developer and operations collaborate and identify maybe a web page is slow, maybe there's a bug, whatever the challenge is, simply iterate on the container, push it out to the repository, and it can automatically get pushed out to the cloud. And my favorite part, if 3 a.m. comes around and there's a bug in the version I made, maybe I made a mistake, previously that was a phone call, now we just roll back to the previous version of the container. It's an immutable container. We can keep both versions around, and we simply just say, version 1 was good, version 2 was bad, go back to version 1, we'll yell at the dev in the morning. I'll actually show this in a very specific example, and actually one that we came across doing the keynote. By the way, fast monitor switching, best feature. So I've got a little app that I threw together, and all it does is it writes, this is a pretty cool app. All right, so kick over, and I'm just going to build that. So we just built that app, and if I run bin debug demo app, it says, sure enough, that it's a pretty cool app. So now how would I actually put that into a container? Well, with Docker, we have a notion of something called a Docker file. And what a Docker file is it's basically directions for building a container image. So I start off and it says from Windows Server Core, right? Just like we did Docker run Windows Server Core a minute ago, it's saying the same thing, start from Windows Server Core. That's our operating system container image. Then I've got a direction workdir / that just says don't go to C Windows System 32, just use C:. Straightforward enough. And then I'm going to copy everything from the bin debug folder into the container, into a folder called demo app, right? And that's what this copy line does. And then I'm simply saying, by default, the command you're going to run is demoapp.exe. That's the command that I want you to run whenever this container starts. And then I just do docker build -t, which says make me a tag, and we'll call this demoapp version 1. There. And so this is off building my container image. So it's starting from Windows Server Core, it's at the working directory, it copied this stuff across, and it set the command to run as my demo app. And so if I do a Docker images now, we see our demo app image, all right? And now if we run it, this time I don't have to specify a command because got to give it the right version there. I don't have to give it a command because I told it what command to run in the Docker file. And so this is going to run, and in a second here we'll see the output from it. Yep, it's a pretty cool app. Straightforward enough, everything works. Would have been great. Oops. That's not good. Hey. All right. But now, I've come back and I've said, I really need my app to be cooler. It's not quite cool enough. And so I found that I can actually call out to this unmanaged assembly, and it's going to do some other stuff, and it's going to be great. And I can save that and go back over, and we'll build version 2. So if I do build now, build version 2, bin debug demo app. Now it's really cool. Works great. Works great on my machine. Life is really good. Now let's go build our container image. So I'm going to build version 2. Same thing we did before, same exact instructions. But now we've got version 2. So we'll run that. So we're running version 2. What do you think is going to happen? It's going to blow up. Why? Because that DLL is part of Visual Studio. That DLL is installed as part of installing Visual Studio. My server didn't have Visual Studio on it, so it doesn't work. And this example came from building the keynote for Build. We were building this really complex website, and the Visual Studio team had done all this stuff, and it was great and wonderful, and it was running everywhere, and things were happy. Then we moved it into a container the first time, and it blew up just like this. And the first thing I got is, there's a problem with the containers. And so we started debugging it, and it turned out no. There was some code in the website was p-invoking into that DLL. And everywhere else they were running it, they had Visual Studio installed because that's what you use for demoing stuff. Not in the container. So it's actually a totally real example of where if we had pushed that actually into production, the whole website would have broken. But not with containers because we're running in the same environment. Now, I can still just simply go back to version 1 because I have that container image sitting there. It's still the same container image that it was a few minutes ago. It still writes this is a pretty cool app. It's not really cool, but at least it works. right? This is some of the power that we have with containers. So I'm going to turn it back over to Arno here, and we'll do some more demos a little later.
Thank you, Taylor. So I guess you have been getting a glimpse on the isolation properties that you actually get with a container, about the speed that you get with a container when you deploy. Now let's talk in a more generic sense about what containers really offer. Number one, and I think that demo also showed that very well, you get very fast iteration. So you can iterate through your code rather fast. You can deploy it rather fast because the unit that you deploy is actually consistent. No longer you install, for example, an application in a different environment from test to production, from developer to test, right? It always brings its own runtime dependencies with it. And by that, you will always know that the result when you run it will be the same. In addition to that, not only do we have proper isolation of the dependencies, or bring the dependencies with it, we also provide resource controls that you are used to. Resource controls that you today find on virtual machines. You can define how much CPU a container gets. You can define how much network bandwidth or file I/O it can get. And by doing so, you allow a very, very proper model where you can co-host those applications inside those containers on the same physical system. You can provide very good SLAs by doing so. And I do believe the example that Taylor showed also shows that you can do very, very rapid deployment. Because the environment is rather small, the environment can be shared through this layered mechanism. You can quickly deploy, run it in that container. There's no huge infrastructure that you need in order to bring that to life. And last, or almost last actually, you have very good state separations between those layers. As each layer is immutable, and actually the next layer only brings the differences with it, you can contain the state, specifically the configuration state of each layer properly from each other. And last but not least, because they're immutable, you can rely on the same execution, on the same functionality every time. Now, when we were working at the booth the last couple of days, I very often was asked, so what do you use them for? How is that different than a virtual machine? And the answer to that really is, it's a new paradigm how you think about development and deployment. And containers can be used for a wide variety of workloads. Let me start here with distributed. Distributed computing really means you have multiple services or workers of some kind that work in an orchestrated way together. Now, containers allow you to properly isolate each of those workers, and by that, you can distribute them in your environment. They can talk over the network without having the overhead that each of them needs, for example, a complete OS. You can use them for distributed computing if you think about different layers in respect to computing itself. Let's say you have a front end, a middle tier, and a back end. And they might have different workers. And in your deployment scenario, one of those layers needs to be scaled. Traditionally, if you have a golden image, the only thing you can do is actually you scale the whole thing every single time. If you have a distributed architecture, you can actually, for example, scale the middle tier all by itself and leave the other two tiers alone. So you will save a lot of resources. In addition to that, containers start up really, really quickly, which makes them ideal for scale-out scenarios as well. The same is actually true when you look at a task-based scenario. Let's say you have some image transforming service. So you take some image, do some work on it, spit out the result. Once you've done that, you don't actually need the operating system instance and the application instance anymore. It has fulfilled its purpose. Now, containers are really good in this, because every single time when you start such a worker to do such work, it will always start with a clean environment. No longer do you need to worry if that image that you processed or the data that you processed has dirtied your environment and makes it unstable in some way. Now, looking at databases, and I'm very sure a lot of people are amazed when we list databases here as a good candidate for containers. The reason why we list databases here as good candidates is simply databases do a tremendous job in separating configuration data and data that was created, data that you typically care about, data that is most of the time the actual value of what this process did. For containers, we do believe it is a good idea to separate, just like databases do that. We do believe it is a good idea to have the data that you create live outside the container itself, just like databases do that, well, with a database. The configuration state of the database is within the OS. In the container sense, it would be within the layer. And by separating those things, you can easily share those image layers and repurpose them multiple times. And last but not least, obviously, for web workloads, this works really well as well. For web workloads, you specifically want to have good isolation between those individual entities. They should only see their own file system part, for example. They should only be able to consume a certain resource amount. And all that is provided by containers. Now you can say, I can do that with VMs. And that's absolutely true. However, if you want to scale those web loads with VMs, you have to distribute the image and restart those. With containers, it is much easier to do that because containers are much smaller entities typically. And they start up in seconds, not in minutes. Now, we talked a lot about what containers are in general. Now, from our perspective, in our version 1, we will support a server scenario within the containers. We will support headless scenario as a start. And so we have 2 operating systems within Microsoft that really fulfill that scenario. And I start with the more traditional one. Windows Server Core is an operating system configuration that doesn't come with its own UI. You have command line, and that's about it. But it brings the full API surface of Windows with it. So if you have existing applications that take advantage of the rich Windows API set, you can run them in Server Core in a container. Then we have forward-looking, what we call born-in-the-cloud applications. And born-in-the-cloud applications are trying typically to not get too involved with the operating system. And what I mean by that is they rather call a small set of APIs in the operating systems, so to be more independent, to be more portable than traditional applications were. And for that, we have NanoServer. It's a highly optimized operating system variant of Windows. It still brings a Win32 API with it. However, that Win32 API is focused on the services that are also enabled within NanoServer. And I encourage you to come to the booth and talk to our specialists about NanoServer as well. Secondly, as another dimension here, we will provide 2 runtimes. And what I mean by that is we have 2 isolation containers that we provide within the Windows operating system. The first one is Windows Server Containers. And Windows Server Containers is the traditional approach to containerization in the OS. As I depicted before, it uses a shared kernel model and then individual containers that are really living in the user mode. You might have, however, more stringent isolation requirements in your environment. If you just think about, for example, compliance. In compliance, it might be not acceptable that multiple workloads share an operating system kernel or any parts of an operating system that is running, for that matter. And that is where Hyper-V containers really come in. With Hyper-V containers, what we did is we took the Windows Server container and put it in a Hyper-V partition wrap. And by doing so, we have all the benefits that we have gained with Windows Server containers in respect to the flexible deployment, in respect to the layering, in respect to the tools that we use. And at the same time, we added an additional layer of isolation that is even backed by hardware properties as well. And with that, I would like to hand it back to Taylor.
Thanks, Arno. So we just talked a little bit about our 2 container runtimes. I think one of the more important and powerful things about the 2 runtimes is that they actually use the exact same image format. So if an image was created using a Windows Server container or created for Windows Server container, it works in Hyper-V containers. If it was created using Hyper-V containers, it works in Windows Server containers. It really is a runtime, deployment time option. To the extent that what we see is, just using our same Docker example, you'll be able to say Docker run dash Hyper-V container or Docker run dash isolated, and that will start up a Hyper-V container. If you leave that flag off, it's a Windows Server container. It literally is, at the management layer, a 1 flag difference between the 2 container formats. And by virtue of that, all of the container management tools that we're working with, and all the ones we foresee others working with, will be able to do Windows Server containers or Hyper-V containers in exactly the same way. Right? We think it's really important that we give the flexibility to the IT pros like yourselves to identify the right workloads to run inside of a Hyper-V container, because you've got a compliance need, because you need that level of isolation, while not having to worry about whether this tool is going to support it or not, or whether this environment is going to support it or not. So let's actually look at what some of this might look like deployed on a machine. So we've got our physical machine, and we've got a Hyper-V virtual machine, right? Now, of course, we can run a Hyper-V container right next to that Hyper-V virtual machine. Makes sense, right? And we can run a Windows Server container right next to that Hyper-V container or right next to that virtual machine. Right? So we can run containers on bare metal, totally fine. Now, the Hyper-V virtual machine and the Hyper-V container, those require that we have the Hyper-V hypervisor present. Right? Those technologies both take advantage of Hyper-V. Make sense? So now let's look at it another way. We've got our virtual machine. We can run a Hyper-V container inside of a Hyper-V virtual machine. We can run a Windows Server container inside of a virtual machine. And actually, the only place that we need Hyper-V in this case is right there, right? So that means that any hypervisor that supports virtualizing the VT instruction set, the things that are necessary to run Hyper-V, can run a virtual machine running a Hyper-V container inside of it. Right? I think this is really important. It means that we can run the Hyper-V containers anywhere. We can run Windows Server containers anywhere. There's no real limitation on where those container types can run. Right? So we give you the isolation property, and we allow it to run anywhere that it's necessary. Our real goal with a lot of this work was to bring the right tools to you. So we've got our cloud. You guys should be well versed in the Azure and on-premise and service provider offerings that we have with Azure Stack and all of the great things we've been talking about this week. And then we've got our choice of container technologies, right? We can run Windows Server containers, we can run Hyper-V containers, and we can run Linux containers in all of these clouds, right? You can go to Azure today and get a Docker image out of the gallery straight away and start running Linux containers go nuts. Tomorrow, you'll be able to get a Windows Server container image out of that as well. Not literally tomorrow, but soon. And we give you a choice of container management. We're working in the open source with the Docker community to bring Docker to all of these. And at the same time, we're going to have a Windows PowerShell in-box experience for the folks who want to use PowerShell. And we expect that there's going to be many other container management solutions that come around, and we're going to work with them as well. Right? It really is a matter of you guys use the tools that work best in your environment, whatever those tools are. And then for our development friends, we've already demonstrated Visual Studio integration at Build, so you can actually right-click right on a web property and say publish, and it'll publish to a Linux container. That same functionality is going to work for Windows containers, as well as Eclipse has integration with Docker already. And by virtue of us working with the Docker ecosystem, we're going to gain that same functionality natively in Docker. And of course, all of these work with whatever different programming languages you want to use, whether that's .NET, whether that's C or C++, Win32 applications, Go, all the different application platforms that Windows supports. And as well, we've got tools like Service Fabric. Now, Service Fabric allows you to just write your application, and we'll take care of running it in the right technology. And as we bring containers in, Service Fabric will use containers to run certain parts of the workloads in. The workloads that need to be run in a container, they'll run them in a container. They'll take care of it for you. Of course, there's also virtual machines. We're not getting rid of virtual machines. They're not going away tomorrow. There's a huge amount of things that virtual machines are the right tool for the job. And they're going to continue to be that way. And then, of course, we have containers. And so really what we're trying to say is we're giving you more tools in your toolbox. Service Fabric is a new tool in the toolbox. Containers are a new tool in the toolbox. We have our existing tools from the toolbox. We have virtual machines, and we have our clouds. And so it's really enabling you to use whatever tools are best in your toolbox.
And I think it's also very important to understand that containers are really a new way of deploying applications. And I said before, they're a new way of developing applications as well. However, it doesn't mean that you have to write an application for a container. There is no SDK. You write and continue to write an application towards Windows. Your target is Windows. The only difference is how you package that functionality inside in order to distribute it and deploy it. Right? Now, that's very important that this is just a small set of languages and frameworks that we will support. Essentially, we will support just simply Windows, existing applications and new applications. Also, what is not listed on here, just like virtual machines won't go away, even though there are scenarios where you want to have physical deployments as well. It's just another tool set that you have available to make the most out of your infrastructure according to your needs at the given situation.
A couple more slides and we got more demos.
Yeah. So we hope with this overview, you gained some insight on what we think about containers, what we do about containers. You gain some insights of where containers are appropriate. For example, because of the abstraction layer that we do, you don't want to use containers if you need access to physical devices, right? Just like a virtual machine is not appropriate for that. I hope you learned that we provide you a wide range of options in order to cover your scenarios. If you need stronger isolation, or if you're fine with just co-locating applications within the same operating system environment. I hope you understand that there is a very small new tool set that you need in order to manage those containers. And I hope you understand that we are working very, very hard to make it easy for you to have the whole life cycle of containers covered in a coherent way. So with Visual Studio that you can deploy into a container, with Docker that you can deploy containers in various infrastructures, right? And by choosing to work with a partner like Docker, we gain also additional support through tools that layer on top of that. Now, from our perspective, what we would like to ask you to do next is to look at the next preview of Windows Server that will come out later this year. That will contain our first version of Windows Server containers. And as the tool set is exactly the same than Hyper-V containers, it's the right time to start to get engaged, the right time to look at that. Then later this year, in a release after the first one here in summer, we also will have a preview of Hyper-V containers available to you. And there, you can basically experiment with the isolation boundaries that are provided through Hyper-V containers. Now, we're trying to make sure that you continue to roll out information about where we are, about what containers mean from our perspective. And we have been starting to have a site live on MSDN, where you can read up more about containers. There's a FAQ there that hopefully helps you to understand what we're trying to do. And also, you can follow Twitter. Taylor basically posts new information on Twitter as we go along. Taylor?
So last, before we go back to demos, well, second to last. If you're interested, Hyper-V team is looking for more people. And of course, give us good feedback on our session. And now let's get to more demos. Okay. So you might have noticed when I first started this that there was another image listed, sysinternals. So what that sysinternals image is, well, let's actually look. So let's do Docker history on it. And what Docker history does is it actually says, this is how this image was built. And so what we did first is we said the maintainer was me, we set a working directory, we copied some directory into the container. This is actually a bug in this early build where this will actually be a real directory. We set the password to be something super, super secure. It's got a symbol and a number in it, so it's good. And then we said the command to run is command-c and then ipconfig. Okay, so let's run that container. And we'll see what we actually copied into it. So if we do a docker run rm it sysinternals. So that's going to start our sysinternals container. Again, this started from Windows Server Core, and then we layered some stuff on top. Okay, it's up and running. We've got an IP address. I'll just copy that for later use. So each container can have its own IP address. They can have their own MAC address. We're also going to be building NAT solutions, so you can actually have containers behind a NATed firewall. So as you're starting them up, they can each have their own port. Let's see what we have in this container. Oh, we've got the sysinternals suite. So if we go into the sysinternals, just do this. Oops. We've got all of our sysinternals tools. But if we try to run something like Process Explorer, not going to do a whole lot, right? It needs a UI. That's a UI tool. Right? We said, like, nah, containers and UI, not such a great thing. But we do know that there are cases, especially with legacy applications, where you need to be able to interact to just get it installed and configured. So what we can do is we can connect to the container. So I wrote a little tool that just wraps terminal services, just wraps the MSTSC, and I'm just connecting to the IP address of that container. And this takes a minute here because I've got a little bit of a slow network. So there we go. We're actually terminal served into a container. That's pretty cool, right? Yeah. And now if I go into that sysinternal suite and I can run Process Explorer, oops, not the help though, and I can accept the EULA, right? But this is a very real thing, right? A lot of installers still need to have you hit next, next, next through before they actually work remotely. Now we've got Process Explorer up and running. And this looks very much just like any instance of Windows you'd ever see, right? We've got a system process, we've got interrupts running, we've got all these things kind of going on, right? What's really neat, though, is if we go look at Task Manager, and we look at the details here, if I add the sessions view, we'll see that each one of these things is actually running in a different session number. So we say our session ID. So we see session ID 14 and session ID 15. What's actually happened is that we virtualize the session ID, so each container kind of has its own session entries. Now session ID 0, these are the things that are being shared from the container host. So the session manager, well, you probably only want to have one of those. Makes sense. System, right? The NT kernel and the system. That's shared across all the containers running on that container host. The idle processes and the interrupts, shared across all of them. But then all these other things, 14s, these are all per container applications and services. So, yep, we've got services running. We've got LASSS. We've got this CSRSS. Each container has their own copy of that running.
And the interesting thing about that is we started Task Manager as well, the system internal tools, within the container. And so those tools actually only have the view of what is within the container. So you get a very, very strong isolation boundary. If you run the same tools outside the container, you would actually have, in contrast to that, a global view. So you can see actually all processes that are running on the system.
Yeah, and so here we are in the container host. And so if I go do the same thing, I look at the session ID. So we've got our session ID 0 stuff, fine. Session ID 2, session ID 14. So there's all the things that are running in that container.
And notable because we see session ID 14 and 15 in this case, just simply because we did a remote session into that container, right? Yeah. Which opens a new session by itself.
And so if I came over here and said Process Explorer, and I'm doing this from the container host, and if I now switch back over to our container, oh, I killed the wrong version of Process Explorer. Gotta kill this one. But if I killed the right one, it would have gone away. Because the host has that view of it. Okay? Neat. So let's say what I'd really done is I'd installed something cool in this container and I got it all configured and it was set up the way I wanted it to be. So what I can do now is I can actually exit, except I specified RM. So I've thrown away the sandbox. What I was going to do is do a commit. Well, let's do another one. We'll actually do it a little differently. So we'll say docker run minus IT Windows server core. So this time I didn't specify --RM, so I'm saying I actually want to keep that container sandbox around after I'm done. And why I'd want to do that? Well, I'm going to pretend I'm installing something in here. So instead I'll just do dir to foo.text, because foo.text is really pretty cool stuff and it's important. So when I exit, we're keeping that container sandbox around, so if I do a docker ps, it's not going to show anything running, but if I do a ps -a, there we go. That's the container I just ran. So we can see it exited 27 seconds ago. Docker gives every container an interesting name, so it's always kind of fun to see what name you got this time. And we've got a container ID. So if I do a docker commit of that container ID with a name, what I've actually done is I've now said, take that sandbox and make it an image. And so if I do a docker images at this point, there we go. There's our container image that I just created. So if I do a docker run on foo, it's going to look just like the Windows Server core one, except I've now got my super nice file inside, right? the file I just created, foo.txt. And if I create another container with the same thing, if I do another Docker run, it would do the same thing. It would have that same container image started up. They're all sharing the same server core image, but we've just created a new layer on top. And then we've created a sandbox for those containers to run in. Cool stuff.
You like it?
And again, each container has its own IP address. They've got their own name. So if I do a set computer name, it's got an auto-assigned name. And we'll allow that name to be specified as a redirect. One of the questions we keep getting, we get a lot is, what about Active Directory? Can I join a container to Active Directory? Well, joining a container itself to Active Directory is kind of a weird thing to do. Because just like I created that container image, if I joined it to the domain and created an image and then started up 3 of them, I just started up 3 duplicate machines on the network. And we know from VMs that that generally doesn't go over very well, right? But what I can do is I can do things like a net use. So I can use domain credentials within the container against other machines, right? Often what people are doing for authentication with containers is they're actually using certificates. So they're putting a certificate in when the containers are started so that they all have a way of communicating with each other securely. But if that container was to get lost, that image was to go somewhere else, yeah, they don't have the certificate, so no problem, no harm, no foul.
And what's also important, the way we achieve that those containers actually start up very quickly, despite the fact that they always start from a clean image, is that the information that Taylor was referring to, like the computer name, like potentially if you want to have a static IP address, those things we just simply inject into the container at startup time. There is no setup process that the container goes through in order to come up. That's also very, very different from Windows traditionally.
Yeah. And so we'll be able to do things like expose directories into containers. So I can do things like, say I want the C drive at folder foobar to be mapped into this container's view. That's how we do things like databases, right? So we can separate the state away from them. Now it's going to be your job if you want to remove that container image somewhere to copy the files with it, but that's how you enable stateful applications with containers, or you use the network to copy, to direct the database over to a file share. So I suspect that there's probably a decent number of questions around. That's what our experience has been. So we've got mics around. We do ask that if you have a question that you use one of the microphones, and we'll try to kind of go in an orderly round robin to get everybody a chance. And we'll leave this up, so if you have questions, you want to see stuff, we'll try it out. Yeah?
Can you show the size of these containers?
Can I show the size of the container? I don't have a real good way to show the density, the memory usage of a container right now. I can't think of one offhand. Yeah.
So actually in respect to the hard drive, if you remember that we use those images that containers share. So those images are in a repository, and when you start up a container, we actually only refer to those files. We never actually duplicate them because they're read-only copies. They're read-only files, right? They're immutable layers, and so there is no copy actually. The footprint that you have on a container is literally what you actually write to the system, the new state that you create. And that is largely also true in respect to the memory footprint. So just like with virtual machines, you have to be a little bit careful when you ask, or about the context when you ask, how big is a virtual machine? How big is a container? Because it really depends what you run in there. If you have a large framework, your container will be way bigger. Your container will take longer to start, right? So that's something to keep in mind.
Yeah.
Another question is, like the virtual machines, we are able to make them highly available, disaster level. How to do that with container? Like if the host of the container is dead.
Yes. So when I talked about containers before and how we think about structuring containers from where data resides, ideally you want to have data living outside the container realm itself. Now, that could be on the local host, or that could be somewhere remote within your network. And that really also, again, depends on your workload, what the right solution there is. Containers per se, we don't have a plan to build availability technology into the container. Now, having said that, though, technology like the service fabric allows you to specify the amount of instances you want to have in a pool of a certain application, right? It gives you the chance to specify the availability requirements that you have, and then actually entities like the service fabric, they just will use containers at the back end. So it makes more sense to actually bubble that up and have that live in that layer instead of us implementing that at the lower level.
Maybe using virtual machines and Hyper-V
Yeah.
make them.
That's absolutely possible as well. And actually, if you look today in the cloud, typical deployment of containers, what happens is that people buy a virtual machine, start up a virtual machine in a cloud, and then they run Docker inside and basically subdivide that particular virtual machine with their containers, right? Okay, you're welcome.
Question?
Yeah.
So, can you clarify what's actually running inside the container? I'm over here at number 1.
Gotcha. I'm looking around. There's
I know. So, is a full Windows operating system image running inside each container?
They have a view of a full, well, Windows Server Core or Nano Server operating system, yeah. And actually the image that we will transport, the container OS image, will be largely a full version, but it's going to have some differences in it. It's really meant for a container.
Okay,
Right.
so then the container itself contains that underlying image and then whatever parts and pieces of applications that you want.
Right. But when you transport, you only transport the application pieces and parts.
Got it.
The container OS image comes from the cloud.
Just there. It's
Yeah.
almost like AppV for servers. Maybe that's oversimplifying it.
It's
Well,
AppV is
we tried-
another type of isolation technology, and so there is parity kind of conceptually there, but this is a much stronger level of isolation than what
Right.
AppV typically did.
Great, thank you.
So,
Okay.
so traditional Linux containers have, I guess, networking, so it's bridges. What's
Yep.
networking there? And we can talk about security.
Yeah. So, I mean, as we said, so in networking, this is actually the way that Docker's going as well. Each container can have its own IP address. It can have its own MAC address. It actually hooks up to our virtual switch. And we're going to build NATing capability to do very similar to the bridge approach into the virtual switch. So you'll be able to say at the virtual switch layer, this is a NAT, and please give me NAT capabilities out of that virtual switch. So we kind of get the best of both worlds. We can use all of our P2V, our provider addresses and consumer addresses, all of our network virtualization tricks and technologies, as well as just using individual IPs, or we can do NATing. Kind of get both.
And what about security?
And what about security? So we believe both Windows Server containers and Hyper-V containers are going to be highly secure. Frankly, we won't ship things that aren't secure. And if we do find things that are, we find bugs, we fix them as quickly as possible. That's always been our position. So yeah, we believe containers are going to be a highly secure environment.
So in regards to the one gentleman's question about how they appear like on the disk structure in the file system.
Yeah.
So when I create a container and I have it in the repository, I mean, I assume that it exists in the disk structure. I mean, is it like a flat file?
It's actually going to be an exploded set of files out that we're going to take care of behind the scenes. So it'll be in a magic directory that you can set somewhere.
Okay, so it creates a directory and I don't look at the man behind the curtain, basically.
Right.
Okay.
And we're gonna try to make the man behind the curtain a little more of a formal curtain, so it's hard to even get behind.
You know, some sort of isolation.
Yeah. But
enough. That
you know,
makes
if you look at it, it's going to be a set of files and
Okay.
registry hives and stuff.
The important part there is that no container can actually peek in the other container's directory, right? So you have proper isolation. But just like in any hosted scenario where you have an underlying shared environment, that whatever runs that shared environment, that has to have a global view, and that is true for containers too.
Okay. So I can actually. So I can actually install like 64, 32-bit applications into the container. It doesn't necessarily have to be that they exist already on the OS and they simply are binaries that are being executed from within a container.
Well,
You can install those applications into a container image by you basically install it into a container, and then you commit the container, and that makes that image an object now, and now you can start containers and run those binaries, or you could run them from a network share, or you could copy them in at startup time.
Central to local.
Yeah.
Sure. Very good. Thank you, gentlemen.
Huh?
All right, two quick questions. How does memory consumption scale with container activation? And what Microsoft products will be supported to run inside containers?
So in terms of Microsoft products, I'll start with that one. So we're still looking at what exactly products are going to be supported at day 0 with containers. There's a couple that are certainly high priority, SQL, IIS, those kind of things, but we expect there's going to be a broader set of applications coming over time. A lot of that's working with the product teams to identify what's the right set of scenarios and places to use containers for it. And in terms of memory scale, so as we start new containers, there's some, the services have a backing amount of memory. So they are going to consume some memory. At the same time, we were able to use some levels of deduplication type technology, so the containers can actually reuse parts of the common memory set. As we get a little bit further along with the container development, we're going to have more real density and kind of size data available.
But again, keep in mind, it's really workload dependent, right? So if you do comparisons between different environments, you essentially really need to run the same applications in order to make a meaningful comparison there.
Question.
Let's get him. He's
All
waiting
right,
for
sorry,
me.
kind of eager. Kudos on the great work, guys.
Thank you. Thank you.
A couple registry-related questions. So will Windows-based images be on the Docker Hub? Will you guys support official images, and what's the time frame for that?
Yep, so yes, Windows, so the container OS image, the actual part of the Windows image, will come from a Microsoft location, but we will redirect it from the hub so it'll look the same way. Okay. The images that people create, images that we create, will go to the Docker Hub. That is our plan and commitment. And so yeah, we will have them available there. We've actually already started the work with Docker to be able to differentiate between a Windows image and a Linux image.
Especially when browsing from like the web or something.
Yeah, well, and even locally. So if you're on a Windows machine, you say Docker pull, we don't want you to get a Linux image that doesn't work. That doesn't help anyone.
And what's the time frame?
So we'll have a preview this summer, and then we're going to continue going from there. It will be part of Windows Server 2016.
Okay, great, thank you.
Yeah.
Question, can you cluster the containers, or what is the roadmap on that?
So we don't cluster containers like we've traditionally done with virtual machines, like through failover clustering. You can cluster them in terms of orchestration tools like Docker Swarm or Mesosphere or Kubernetes, where you kind of create a cluster, a ring of things that activate containers in multiple instances. But it's not you don't model it the same way as a virtual machine where you really care about that one virtual machine. You care about the container image, you care about the ability to start another one, but the actual one that's running right now, if it has a problem, you just let it go and start a new one up.
So can you create a resource, a cluster resource for a container and fail it and fail over? Or?
No, not today. That may come, and really it's going to be feedback from folks like yourselves. If we get the feedback that that's what people really need and the scenarios work, then we'll figure out how to make it happen.
So if we have production machines running on the containers and they're running on the underlying Windows host, if we have to patch this host and we have to reboot it, is there a way for containers to kind of vMotion itself to another host, or will everything go down? So
ultimately, you can so with like Docker Swarm and all the orchestrators, you can say scale this host out, basically drain it out, and it will stop those container instances and start them up somewhere else.
But still, there's a downtime on that.
Yeah.
Yes, but keep in mind that containers start very, very fast. Right? It's very different than starting a complete OS image from scratch. And the other thing is architecturally, what you want to make sure is that you have what I talked about before, separation of data and container state. The data is the thing you care about. The container state, hopefully, you don't care so much about. And by doing so, you enable a much more flexible scenario where you can really subdivide your application in different layers and deploy it, distribute it in the environment. I do understand that doesn't necessarily apply to existing applications. For existing applications, what I think is the right thing to do is try to make sure that you can write your data to either a share of some kind or a location of some kind. And technically what you do, you configure your container that that location is actually outside of the realm of the container itself, be it on the physical host or being in the network.
So there's
somewhere.
a possibility to connect, for example, SAN directly to a container?
SAN, well, it depends. The answer there is depends, right? Conceptually, because it's OS virtualization, you actually don't want to have driver dependency all the way into the container, right? That should really stay in the host. And you should use abstractions like file shares or protocols like SMB to actually map things like that into the container.
So if the SAN is connected to the host, the containers will see the space.
Right.
If you make it available to them.
If you make them, if you tell them to. Yep.
Can you talk about the patch management strategy for containers?
Yeah. So let's assume the hardest part of the worst case is that you have to patch the container OS image. And so if you patch the container OS image, then you actually need to rebuild the container images that live on top of that. And that's where the tooling like the Docker file comes into play. Because that's really the instructions on how to build a container image again. So you create those instead of just manually creating a container image. And so if you do have to do that, you just simply run a Docker build again and re-push those into the repository, and you've got a new set of container images to push out. Make sense?
Yeah, thank you.
Yeah.
Okay, I think.
Hi, I'm Jeff Leeson from YP. I actually have two questions. The
Sure.
first one is you mentioned Kubernetes.
Yeah.
And that's actually, one of my questions was around orchestration of the resources. Obviously there's, we have existing tools, virtual machine manager, Azure, et cetera, to be able to allocate tools, provision these microservices, and orchestrate them. Do you guys have any specific plans or thoughts to integrate into existing open source communities that are already doing that, or tacking on that feature and functionality into other System Center products or Azure products?
So we've actually already been working with Kubernetes and Mesosphere and Docker with Docker Swarm. So we've already got those three that we've been working with, and we're going to continue to work with them. We conceivably will do some integration with other parts of Microsoft products. That's probably going to happen. But we certainly are going to continue to work with the open source communities. So again, Kubernetes and Mesosphere and Docker Swarm are the three that we've been working with the most thus far. But if there's one you think you'd like us to be thinking about or looking at, shoot me an email, let me know, because
Mesos, Marathon, Zookeeper, those are all the ones we're deploying. So say the right ones.
Marathon is another one that was on the list as well to start working with,
My other question was about specifically around the open source community and keeping it unified. How much are Microsoft employees committed to committing their own time to the Docker open source project to try and keep the two branches, the Linux side and the Windows side, unified in secret management, how to access local and remote storage?
So they don't actually have to commit their personal time. We're paying them to do it. So we've actually got a branch that we're RIing changes or pulling changes into Docker main right now. Anybody can look at it. It's GitHub, repository, Microsoft, and Docker. And so, we're actively working with them in partnership with open source to do that. And so the way the actual architecture works is the bottom edge of the Docker engine has a set of drivers, a compute driver and a storage driver and a network driver. Today, those are Linux-specific drivers. They call Linux code. We're making Windows versions of those. So the upper layers stay the same. And then we're working with the community on problems like the backslash versus the forward slash. And how do we do that in a meaningful way for both Windows and Linux? How do we do authentication across both platforms? There's challenges there. But our real commitment is to make sure that these things work so that you can have an application that's part Linux. Maybe it's a Linux backend and a Windows front end, or vice versa, any combination of those, and use the same tooling to manage them.
Okay, great. Thank you very much. And thank you, by the way, for jumping on this so early.
Yeah. Well,
I have a question related to a sort of complex application environment where you might traditionally use something like inter-process communication. If you have one container which represents one app environment and another container which represents a different app environment, is there any way that you can emulate what would normally be used as inter-process communications to make them aware of each other and potentially share information, data, state?
So we generally look at networking as the main way to communicate across containers. Now, a container can run multiple processes inside of it, and generally you try to avoid that, but there are some cases like inter-process communication where that's necessary. But overall, we generally prefer to have more formal exchanges of information over network protocols and those kind of things.
So that would be related to the unique IP and MAC addresses that the containers have then?
Yep.
Yes. Okay, thank you.
Yeah. We'll take a couple more quick questions, and then we got to get off stage, I guess.
Yeah, 2 questions. One, will you support Docker Compose both in the on-prem as well as out in the cloud?
Yep. So we actually already support Compose in Swarm and Azure, and we actually think Compose will just work with already, but we're committed to that.
Okay. And then when you instantiate a new container, can you add a volume at that point, or only once it's deployed through like a net use?
You will be able to add it at deployment time. So Docker has the dash volumes option. We will be supporting a similar notion to that.
Okay, thanks.
Yeah. So thank you, everybody. I'm sorry we're out of time. We're going to be available at the booth to answer further questions. Thank you very much for coming here. Thanks for giving you your time.